Hello everyone, my name is Satyajit Pattnaik and I welcome you all to my channel and to this brand new episode on generative AI. When it comes to generative AI, when you are working on different use cases, it could be a simple chatbot or a RAG-based system or maybe fine-tuning large language models. There are choice of LLMs that you can choose from, right? There are different set of LLMs available via APIs and there are different set of LLMs available open source. When it comes to APIs, there are some API providers like OpenAI, which has different versions of GPT, XAI, which has different versions of Grok, and easily you can go to their platform, just add some credits to it, create an API key, and you can easily start working on a project. But the downside is that you have to spend something, you have to do some sort of investment to get started working with APIs. On the other hand, open source models are completely free, available on Hugging Face or Ollama. But the downside is those models are very big models. I would say there are different type of models, right? When it comes to Ollama, I'm taking an example of Ollama. In Ollama, there are more than 100 models. Some models are trained on 1 billion parameters. Some models are trained on 4 billion, 3 billion, 7 billion, 13 billion, 20 billion, and even more than that. There were some models with 70 billion parameters. Just imagine how much CPU strength do you need to run those models. You need a very high-end CPU or GPUs, especially when you're running models like 20 billion or 70 billion. You cannot run it on CPUs. You need some strong GPUs. So that is the downside, and everybody cannot afford GPUs, right? But on the other hand, you always have a choice of choosing a smaller model like a 1 billion or a 2 billion model and try out with those kind of models in your laptop. So it depends based on what kind of system you have. You can actually choose the LLM models for your particular task. So in this video, we are going to focus on the open source models. I already have multiple projects related to generative AI, chatbots, and various other things on my channel. And most of these projects are using APIs like OpenAI or Grok AI. And many people have already told me that, sir, come up with open source models because we do not have the bandwidth to do some investment. So here we are. In this video, we are going to talk about Ollama. Ollama is a very special tool that basically gives you it helps you to choose some models that you want to run based on your own configuration. I'm sure you will have a very good idea about Ollama and its different models once you go through this video end to end. This is going to be a very long video. What is going to be covered here is Ollama. What is Ollama? What are the different models available in Ollama? How to get started with Ollama? How to test different models with Ollama? And RAG systems with Ollama. We are also going to create multiple projects with Ollama. So this is going to be an end-to-end video. I'm pretty much sure you will love it. In case you love it, like it, please like and share this video and subscribe to the channel. And also let me know in the comment section if you have a specific requirement. For example, if you want me to work on a banking related generative AI project or a medical related generative AI project, let me know in the comment section. If you have a very specific description of the project, then also you can let me know in the comment section and I will definitely come back with that video. I will let you to get started with this video. Enjoy, and any questions, reach out to me on my social media handles. See you in the video.
Hi, welcome back. In this series of videos, we shall be discussing our next model, which is Ollama. So, what exactly is Ollama? To get started with, in simple terms, let's try to explain. Ollama is nothing but an open source tool. Okay? And it's an open source tool to simplify the process of running large language models on your local hardware. Now imagine, I just talked about large language models of being different types, right? Some of them are used via APIs or accessed via APIs, and some of the examples are OpenAI and various other like Grok, and even some of the models are available through Grok APIs. And apart from that, the second category is open source, right? In open source also there are multiple types, like Hugging Face is also there, which has like hundreds and hundreds of transformer models, hundreds of LLM models. We also have low Ollama and various other things. We are focusing on this part. Why? Why are we focusing on Ollama? Why even do we have a module on Ollama? Because Ollama is super easy to get started with and super easy to start working with open source models, because you do not have the tension, or it's a very hassle free process, because you do not go search for the models, download them, physically place it in your systems and start working on them. It's using Ollama is very simple. You just install Ollama. You can go to ollama.com, just download. You will be able to see multiple versions of it: Mac OS, Linux, Windows. Just download. Once you download, your Ollama will be up and running. It's not running in my system because I will make it up and running very soon. And once it is up and running, it's just a piece of cake to run different models. It's very easy to use. Okay, so what are the features of Ollama? Some of the features are, let me write it down. Some of the features are, we can build local large language model applications using Ollama, and that's the biggest feature, right? Now, if I have to differentiate, uh, we can write it down as, we have customized models. We can use different Ollama models. We can build RAG systems powered by Ollama models. And then we can also build full-fledged AI based application or LLM applications using Ollama models. So these are all the features. Okay, now let's try to explain you what exactly is Ollama. Like, how does Ollama work? Now, if you talk about Ollama, right? So Ollama is, you can call it as a Docker, kind of a Docker concept. It has multiple large language models inside it. It has Mistral, it has Llama, and when I say Mistral, different versions of Mistral, right? When I say Llama, different versions of Llama: Llama 3.1, 3.3, 2 point something, Tiny Llama, and various other things. Then we have Mixtral, then we have Gamma, then we have various other models. DeepSeek is also available. DeepSeek. And by the time you are going through this video, there might be even more models. If you go to ollama.com/search, you will be able to access multiple models here, right? Now, depending on what exactly your task is, are you going to create a text based application or vision, or you're just worried about the embedding models? There are a lot of them, and if you click on the newest, you will be able to see the newest is something 𝐓𝐢𝐦𝐞 Deep. I don't even know about this, maybe a very new model updated 8 days ago. But yeah, most popular is basically Gamma, DeepSeek, Llama 3.3, and every model has different type of characteristics. If you can see, Gamma has 1 billion parameters, 4 billion parameters, 12 billion, and 27 billion, right? So if you go, you will be able to see that 1 billion parameters is like 800 MB, but 27 billion parameters is 17 GB. So to run this Gamma 3, you would definitely need a GPU, or even if not a GPU, very high end CPU. So if you are using some cloud services like AWS or something, then you definitely need a very higher version of EC2 instance. T2 micro or T3 large, even those things will not be able to run these models. You can still run it on T3 2x large, but the system will be slow. If you go for a P2 instance, probably you can easily run these kind of models. Okay, so now for those people who did not understand about EC2 instances, I'll just quickly show you. I think it's not related to Ollama, it's just that I just tossed that topic of which type of instances can you use. That's the reason I'm just showing this. So if you go to AWS, when you launch an instance, what is an instance? Instance is nothing but a virtual machine, right? Like if your system is not super strong, your computer or your laptop, then you can potentially take help of cloud services to run these kind of applications, right? Now, if you take a EC2 instance, first of all, you can take Linux or Ubuntu, whatever your choice is, and then this is where I was talking about instance type. You cannot really run an application in a T2 micro because it only has a one CPU with 1 GB memory, right? Currently, for some of my official work, I'm using a 2x large, but this 2x large, even though it has 32 GB memory and 8 CPUs, it still is not able to run like a 7 to 8 GB model. The latency is around 20-25 seconds, which is not good. So if you have to run, either you take a um, like a higher version. Like there was a P2. Yeah, you can take these higher versions as well with more CPUs. Of course, the costing will be higher, but give it a try. Or else, if you have a laptop or a desktop with GPUs, you can run these kind of models. Okay, now jumping back to the next topic, how do we get started with Ollama? Now, before getting started with Ollama, which we will cover in the next video, we will have a detailed step on how to install, how to get started with Ollama. Let's try to talk about the next topic, which is what problem does Ollama solve? Okay, so let me write it down. What problem does Ollama serve? Right, now let me just copy this so that we can write down in a similar fashion. So, okay, before talking about this topic, let me also try to do a simple RAG based architecture. I know everybody knows about RAG. In case you have not gone through RAG videos, I will recommend you to go back and read through RAG. But anyways, while talking about these model overviews, I will still be tossing a lot of times about RAGs and various other vector database architecture. So you will still be able to refresh your memories, no problem. Now, what happens is, so usually you are dealing with documents, right? Now, documents, what happens is the very first thing that we do with documents is chunking down, right? So let's say you create a chunk 1, then a chunk 2, and then dot 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 chunk n, right? And then after the chunking down is done, then you basically create your embedding model, right? Let me use a different color so that looks wow better. So I have an embedding model. Okay, now what does embedding model does? It basically creates embeddings, right? So let's say I have different embeddings, embedding 1, embedding 2, and so on, right? So let me draw these embeddings like this, right? Now what happens is when you have a user query, so the user is standing here and the user has a query, right? Now, what happens? First of all, the query goes through the embedding layer, right? Whatever you do with the original documents or the custom documents, you do the same with the queries, right? And then you generate a query embedding, right? Very similar to your document embedding, you create a query embedding. Then what happens is you go through this and then eventually get the most similar embeddings, right? Most similar embeddings you get, and this is where you call your generative AI model or your large language model, and then you provide the response to the user, right? This is what a rack based architecture looks like, right? Now, what problem does Ollama solve? The reason why I drew this is because most of our use cases is around RAGs, right? Retrieval augmented generation. So some of the problems that Ollama solves is, the very first problem is, try to open up your brain and think about it. When you are using APIs, OpenAI APIs or any kind of APIs, it's very simple. You're going to Grok AI X AI, or let's say OpenAI. I'm not able to show you OpenAI because in Hong Kong we don't have OpenAI. So let's say you are going to X.ai, and then here you're going to APIs and you're buying your API keys and getting started with it, right? Now when you're buying your API keys, that means what's happening is, so imagine there is a brain, Grok brain, right? And here is your application and you're actually calling the Grok brain to get the this part, right? So the Gen AI or the LLM application is not sitting in your own machine or your own server. It sits somewhere we don't know, right? Now there could be a strong privacy issue, right? So first of all, when you are starting to work with Ollama, everything sits on your own machine, whether it is your own laptop or if you are using a AWS EC2 instance, the model sits on your own hardware. So first problem that Ollama solves is data privacy, okay? Because it's a locally running and it has more security. Okay, the second point is, trust me, once we get started with Ollama in the next videos, super easy to get started with. Okay, very easy process. Then cost efficiency, there is no need to worry about cost. Now of course, if you are looking at a very high end models, you need a stronger GPU or a stronger storage, right? Of course there is some cost there, but to get started with, there are also many small models. If you just search for llama tiny llama I think is the smallest model that I have known, around 600 MB, still does the work of, I mean, still does a great work. I have tried tiny llama for a couple of my projects, works. Even on a simple T3 dot large machine it works. On T3 dot 2x large, it also works, like gives answers in 6 to 7 seconds. So cost efficiency, you don't have to worry about API cost and all those things. The next thing is latency reduction. Okay, if you have a stronger storage, you can reduce the latency because these are all local executions. Reduce latency. What else? Yeah, we also have an flexibility for customizations. more flexibility for customization. Okay, so these are all the reasons or all the problems that Ollama is solving. Okay, now before getting into the Ollama setup part, let's try to talk about our last few things, which is key features. What are the key features of Ollama? Let me try to copy the same thing from here. What are the different key features of Ollama? Firstly, it is model management. Then comes unified interface, extensibility, and performance optimization. So all of these are key features of Ollama. Okay. What are the different use cases? Use cases are multiple, right? The first use case is, let's say you are creating something for your development or testing. You are creating like for education and research. You are building some secure applications. So use cases are many. Okay. So that's a very quick overview on Ollama. In this video, we shall be getting into the next steps of installing Ollama and then getting started with Ollama. To install Ollama, it's very simple. I explained um, a little bit in the last video. Just go to ollama.com, click on download. You should be able to download as per your version of the laptop or desktop you're using. I'm a Windows user, so I have already downloaded it. I'll just quickly show you how it looks like. If you download, you should be able to get an exe file like a Ollama setup. I'm just closing it because I already have the setup. I already have installed Ollama, right? So once your exe file is downloaded, just click on it. Next, next, next. I think I don't have to explain you how to install an application. Once Ollama is installed, sometimes what happens is when you install an application, the application is installed and does not pop up, right? And same happens with Ollama. Ollama does not pop up because it's running always on your background. So do not worry if nothing pops up after the installation is complete. Just go to your taskbar and see this icon. If you see something like this, that means Ollama is up and running. Okay, now Ollama is up and running. Now, what are the next steps? Let's try to go through some of the Ollama models that we have. Okay, so I'll go to models and let's try to understand some of the different models that we have. Now, before talking about models, what are the prerequisites? Prerequisites. My handwriting is not great, but I would say it's not bad as well. So should not be a big problem. Yeah. Okay. Now we have the prerequisites. What are the prerequisites? So I usually recommend people to have at least a good storage like 10 GB plus, a good processor, of course. CPU is fine, but GPU is always better, right? So these are the two different prerequisites to get started with Ollama, right? Internally, it downloads, right? Whenever you get started with the Ollama model, even though you don't download it physically, but when you are running the Ollama commands, internally it downloads that particular model in your local machine. So you need to have a good storage, you need to have a good processor to run these kind of models. Okay, so downloading and installation is done. Now let's try to go through some of the models first. and then I will try to explain you what these numbers and what these details are. So let's say I'll go to Tiny Llama. What is Tiny Llama? Tiny Llama project is an open endeavor to train a compact 1.1 billion llama model on 3 trillion tokens. Okay, it's a very small model trained on 1 billion parameters. What do you mean by parameters? Parameters are nothing but some internal weights and biases that are being trained. Now, obviously, the more number of parameters trained, the better the model will be, right? And this model is around 638 MB, and the quantization is Q4O. So, let's say we will be using Tiny Llama for our exercise, because as I'm also recording, I don't want my machine to eat up a lot of memory and CPU. So I will be picking a smaller one like a Tiny Llama in case your machine is even better than mine. Like mine is 32 GB RAM and then like 1 TB of storage. I have a AMD processor as well, AMD Ryzen processor. So depending on what you have, so it's a hit and trial. Just give it a try and see whether your machines are able to use bigger models or not. For this exercise I'm going to show you Tiny Llama. In case you want to use any other models, just replicate my process. Okay, the very first thing is go to your Windows. If you already have Anaconda prompt, or if you are a Mac user, go to terminal, and here what you need to do is first write Ollama. As Ollama is already installed, I am able to see something like this. The usage of Ollama is like this. You use Ollama and then the command. What are the different available commands? Serve, create, show, run, pull, da 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 da. Right. Let's say we'll get started with list. Ollama list. Right now I do not have anything installed. Before this video I uninstalled all of my models so that we can install it fresh. Okay, if you want to clear it happens in the Ollama prompt, like Ollama terminal, just ignore. So let's say I'm getting started with a model. Okay, let's say Ollama. To get started with a model, you can either use a pull command or a run command. Pull command basically pulls the model to your local machine, and after that you have to run this. But if you directly run the run command, even if your model is not available, it will pull it internally and run it. So let's try to directly run Tiny Llama. You can see it is first pulling everything, all the data, and then it will get into the next part and it will run the Tiny Llama. And your console, your Tiny Llama console will be opened directly in this command prompt, like I'm using an Anaconda prompt. So once we are familiar with how to use these Ollama models, our next step will definitely be getting into Python notebooks and start coding and implementing some sort of exercises using Ollama, and then henceforth we will also be doing some RAG based generative AI projects using Ollama. Okay, it's almost done. 637 MB, and you can see, right, the model was 638 MB. So yeah, if you combine all of them, it's the same. Now you can see the model is ready. Now if you ask something, Tiny Llama is going to respond to you back, and it's exactly like ChatGPT, right? Now let's say I want to ask something. Hi, who are you? Hi there, my name is Didida, and I am a chatbot that's designed to assist with how many parameters are you trained on. I'm not sure whether it will answer or not, but let's give it a try. I do not have access to the specific information. However, as an AI technology, it's highly unlikely that the system is designed to. Okay. Okay, so let me ask a general question. When did India get its independence? India got its independence on August 15th, 1947. It was a free and sovereign country after the end of British colonial rule over India. I think it's doing a good job, right? Now, there are a whole bunch of activities that you can do, and this is exactly what we do on ChatGPT, right? We also access ChatGPT to ask something. Let's say I want to ask something that I ask on ChatGPT. Let's say um, I am recording a video on introduction to Gen AI, and I usually start my script as hello, welcome back to the channel. This is Satyajit Pattnaik, 13 plus years of industrial experience, and in this video we shall be deep diving about the topic. Make sure the script starts the way I usually start, have a good hook, and end the script with a question mark. This is for a short video, so make the script really short within, I don't know, I just don't want to bombard with a huge amount of words. Absolutely, here's a shortened version of our script. Opening shot of Satyajit Pattnaik in his office with a notepad and pen. Satyajit Pattnaik. Good day. Welcome back. This is Gen AI, our newest series. Today, we will be discussing the topic of artificial intelligence in the, but it's not doing a great job to be honest. But I think I used a hook. That's why it has changed the initial phrase. But yeah, I just don't want to validate whether the output is fine or not. But let's say we'll go through the script. So let's start with an example, a chatbot. Oh, actually, it has done a good job. Even though I told him that I usually start like this, which is like a one shot prompting, it has still changed the way it should start. Okay, but I do like it. Good day, welcome back. This is Jenny, our newest series. Today we'll be discussing the topic of artificial intelligence in the industry. So let's start with an example, a chatbot. Chatbots are becoming increasingly popular in recent times as businesses look for automation solution. Da, 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 da. Another example is an AI powered ordering system. Actually, I like it. The the benefits of AI are immense for the industry as a whole. Da, da, da. So let's look at some real life examples of how AI is transforming industry. Another example, okay, in conclusion, let me mention that we are living in a world where technology is increasingly transforming. Okay, however, okay, it has done a fair job, but I explicitly asked for a question to end with. Now, if you take the same question and try to go to u.com and ask it, I'm pretty much sure that ChatGPT, which is like internally it is GPT-4o, will be able to give a better answer. Obviously, because GPT-4o is like a huge model as compared to Tiny Llama, and you can see it has copied the same style. and it has given me a hook, and then at the end there is a question. So are you ready to uncover the future of technology and creativity? Because explicitly I had asked to give a question at the end the script with a question mark. Now if I be more specific, end the script with a question for the audience, that will be a better prompt. So anyways, I think you are getting my point. Then that's how you basically get started with Ollama, right? Now once you are in the Ollama terminal, you can do certain amount of exercises. Like there are some options which includes let me try to remember. There are some options like help. So there are options like show show info. Show info basically shows you which model are you running. As you can see, you are running a llama model. So tiny llama is nothing but a part of llama, right? So llama model, the parameter size is 1 billion and the quantization level is q4 underscore 0, right? Now if you want to clear this off, you can clear is not working. I thought clear works. Help. Okay, I think there is no clear. Anything else? Yeah, I think we'll just make it by. Okay, so done. So our basic steps are done. I also wanted to get into one more thing, which is some sort of testing models, but we will do that in the next video. Okay, I forgot one more thing. Now once my tiny llama is already installed, if I go to Ollama list, you can see my tiny llama is already active, right? Let me try to run it. Run. Sorry, oh, I just did a blunder. Run tiny llama latest. Okay, now tiny llama is running. Now let's say I'm doing Ollama, sorry, show info. Only family is showing, parameter size is showing, quantization level is showing. Why don't we see other features like what is the context length and the embedding length? Let us try to install another model. Let's say I will go for a llama. Okay, let's go for a llama 1b model. Okay, yeah, if you go to these models, okay, I think it's showing here. Let's go to tiny llama first. So if you go to tiny llama, if you go to the model, right, here you can see a lot of information like the metadata about the model, right? I was expecting to show all of these things here, but I think it's just showing a few items like family and parameter size. You can see the quantization is shown here. The architecture is llama. What is quantization? Quantization basically means, how do I explain? Basically, Q means your quantization. 4 basically means the number of bits. Underscore 0 is nothing but a version of it. Okay. Um, and all of these things are not required for you to understand. Context length is important. Context length is 2048, which basically means if you give a huge document, it will only take the last 2048 tokens into account, right? Embedding length is there. Embedding length basically means it's the size of the vector representation for each token. And there are various other things. In case you want to understand each one of them, you can take help of ChatGPT, ask what exactly this means, and you will be able to understand. Okay, so moving back, so our this thing is done. So these are all our different LLM parameters. Now next video, let's try to do some testing exercises on our basic uh, Ollama Tiny Llama model, or maybe we can try to install another model and uh, do some testing. Let's get into the testing models part. Now for the exercise of testing, what we are going to do is, let's try to install one another model apart from Tiny Llama, and then we will try to create some test cases like simple questions, and then uh, doing some sentiment analysis, doing some language translation and various other things. We'll try to compare which model is working. So let's say I'm going for a llama. It won't be fair to compare tiny llama with a huge model, but still, do we have one? Okay, we have 1 billion parameters gamma 3. So let's try to run this. Okay, so pull model manifest. The model URL pull requires a new version of Ollama. Fine, no issues. Let me not download a new version of it. I don't want to waste time. Let me try to go ahead and pick some llama models. Let's say I'll pick a llama. Let's try to pick a 3B model. Okay, 3 billion model. 2 GB should not be a big problem. Let's try to do this. Right, pulling manifest. So let it run it, and in the meanwhile it is running, let me try to open Excel sheet, and then we will be creating some test cases. Okay, so test cases. So let me just do it like this, or maybe like this, and then let's say we will run it using tiny llama and also using llama 3.2, 2 billion parameters, 2b. Okay, so let's say the first test case will be, of course, let's say we'll first try to wrap text. Okay, we'll try to ask some basic questions about who was the first prime minister, or let's say when did India get its independence? Was it um, 26 January 1950? I'm trying to ask a question in a way that it will, I mean, I'm just forcing it to hallucinate, but I'll try to test it out whether it is hallucinating or giving me a proper answer. Um, let us complete this, and then we'll also write down few more test cases. My Excel is down, and that could be because of, oh, I think CPU utilization is high, but memory is not high. Okay, OBS is high. Ollama disk space network. Oh my god. Okay, it's very high. Let's see. We'll. So let's say, can you classify our movie review as positive, negative, neutral, and then the movie review is uh, let me use a notepad, and then the movie was not great, but Vicky Kaushal's acting was top notch. Okay, let's try to use this. and then we will see what tiny llama is responding and what llama is responding. And similarly, the last question can be, can you do a translation of how are you to Spanish? Okay, and then we'll ask some out of the context or maybe some random context questions. Let's say my Vodafone bill for last month was $2,000. I'm not sure why. Can you help? These are the 3 to 4 questions that I'm going to test out with. Okay, so in the meanwhile, my model is ready. There is an error. Error loading model. Is it because of disk space? I'm not sure. Anyways, my Llama 3.2 is ready. Let's try to uh, okay. No, it's giving me some error. Let's try to check the logs. Okay, anyways, let me remove this model. Fine, we will try to see a different model, but let's try to test it out with tiny llama. Okay, so Ollama run tiny llama, and then this is my question. Yes, India got its independence on yes. When did India get its independence? Was it da da da? And it says yes. So I'm not quite happy with the independence, with this answer, but let's try to check this answer. Yes, India got its independence on the 15th of August 1947 after more than a century under British rule. More than a century, okay. On August 15, the British government of India announced that India is free. The actual date of independence was as the actual date of independence was 26th of January 1950 as per the Indian Constitution. However, the Constitution of India was not implemented in its entirety. Let me try to ask the same question to GPT 3.5 Turbo. India gained its independence from British rule. The date marks the end of colonial. While India became independent on this 26 January is significant and it's marked the day when the constitution. So this is a better wording, and that is because of the model. So I will not say Tiny Llama is doing a great job. Did not gain independence on this. That date is when the India adopted its constitution and became a republic, which is correct, which is I accept. So here there are some flaws. Now let's try to do this activity. Okay, now I just could not. I will try to use this as a single line. Okay. Now let's try to get an answer. This is an evaluate. It's first talking about what are the different possible categories, but it did not tell me. It did not tell me. Can I just rephrase it this way? Can you classify this movie review? Let's try to do this. No, it's actually not doing a good job. If I go ahead and ask the same question, I will be able to get the answer. I'm pretty much sure. The movie, the review statement, it can be classified as neutral, right? Because there is a negative phrase. However, the acknowledgement is positive. Since the review contains both negative and positive elements, it ultimately balances out to a neutral classification. So, yeah, I'm disappointed with Tiny Llama. Um, Maybe I'll try to rephrase it in a better way so that Tiny Llama can understand, because it's a smaller model. So I understand that it is not able to deal with it. The movie was not great. Please classify this review. Please do a sentiment analysis on this review. Let's try to ask this. I will be disappointed if it is not answering. Hmm. It's giving me so much. Overall sentiment analysis is not a perfect science but can be effective way. But give me the answer. Come on. Please do a sentiment analysis on this review and tell whether it is positive, negative, neutral. Just answer in one word. Neutral sentiment analysis. I, why it is still answering me so many things? I think it's not able to do this. Anyways, I'll move on to the next one. So I'll just mark it as red. It was not able to do this. Can you do a translation of how are you to Spanish? Very simple ask. Should be like como está, and then or else max to max a line. How are you in Spanish is called da da da. So should not be more than one line, and I don't want more than one line here. Let's see what Tiny Llama is responding. And I'm pretty much sure GPT 3.5 will do it really well. I wanted to test this with a Llama 3.1 or 3.2 model, but it's not okay. What the hell? What does that mean? I think it's not doing a good job. So Tiny Llama, sorry, don't want to I don't want to even ask this question because I know it's going to hallucinate and give me some random answers. Tanzanian shillings? What the hell? Anyways, let's try to do bid buy, and I'm going to keep running a different model. I know that we were not able to install. Let's say I'm going to try a Mistral model, but Mistral model I don't see any 1B models. Okay, tiny. Do we have any other tiny models? Tiny dolphin. Uh, llama, llama. Let's try a llama 1B. Not really sure. So the overall agenda of this video was just to test out few models on console. Of course, we will be taking help of Python codes as well because that's our major task. If you do not want to get through this video, of course you can skip this if you want to, and directly jump into the next video where we shall be talking about how to implement Python Ollama on Python codes, how to run our basic Ollama um, um, mechanisms, and then going forward we will be building some RAG based systems using Ollama as well, right? But those who are enjoying this, please continue watching this. So Tiny Llama, even though it's not working really good for these random questions, that could be because of the lower training parameters, or could be because of I don't know what the context window is. Usually, the context window of bigger models like GPT-4o context model is around 130K. Tiny Llama, what is the context window? If I go for a 1.1b model, oh, there are so many models. Okay, so if I go for a 1.1b model, the context window is uh, 2048. Wow, that's really, really low. 2048 is a very low context window. If you look at other models, right, let's say I'm going for a Mistral model, for a 7b model. If you go ahead, you will see the context window is 32,000. If you go ahead with uh, all these APIs like GPT-4o or Grok, they have larger context windows. Anyways, the model is still not able to run, and I think that could be because of my space issue or something. I'm not pretty sure, and I don't want to debug this. Maybe what we can try is I can try out removing the Tiny Llama and then try to install. Okay, and then try to install. Maybe that could help. I'm not sure. But in the meanwhile, I can also use one of my AWS EC2 instance just to see how can we run this model and just see the output. Our main objective is output, right? So let me try to get details and then I will show you how this model works. Even if local machine does not work, our main target is to see how Llama 3 is behaving, right? So I'll try to switch to our AWS EC2 instance. So I have got my instance. In the meanwhile, even if it fails, I really don't care because we can directly run it on our EC2 instance, which is more powerful. And this is my company instance. So of course, I'll not be able to share you details on how to access this. And of course, you will not be able to access because you don't have the private key. So let's say I go to this machine and then I go to list. We have Mistral. Okay, let's try to use a Mistral model because you can see it's a very larger model that we have. So Ollama run Mistral latest, right? And within couple of seconds it will be ready. And let's go back to this thing and have Mistral here. And then what will be the question? The first question is this. We'll try to ask, and I'm pretty much sure Mistral will do a great job. I mean, 100%, no doubt about it. Yes, you can see the answer has to be no because my question was it 26th January? No, it's not 26th January. India became independent on 15th of August. The Republic of India came into existence on this. So very very good answer. Very very good answer. So Secondly, the second question is, can you classify this review? Let's go ahead. The movie review can be classified as mixed, meaning it contains, which is really, really good, right? And you can see that the answers are to the point, not quite long, very to the point, and really good. So let me just wrap it up. Can you do a translation of how are you to Spanish? Just give me como estas and I will be very happy. You can see, done. Very, very good. That's the power of a larger model. And this one should logically not hallucinate and tell me that give me more context or something. And yes, I don't have the ability to access or interpret real world documents such as bills. And you can only do that when you can use your custom data on top of Mistral and make it a RAG chatbot, then only it will be able to answer. But it is still giving you some suggestions, so which is a really good job. And in my local machine, my Ollama Llama 3 failed, which is not a problem to me. But I have just showed you how things works, right? So let me just remove this because I don't want to do. I usually try everything on local on Tiny Llama, and most of my other work I usually do with APIs, either DeepSeek APIs or Grok APIs or anything, right? So that's my output. I'm going to save this. Done. So that brings us to an end to this testing models. Our next exercise is going to be directly jumping into the Python notebooks and run our basic Ollama. Or I think we can do that as part of this. Oh, let's do this as part of the next video. Directly jumping into the Python notebook and getting started with Ollama, and then we will jump into the RAG systems of creating RAG systems using Ollama. Let's jump into the next part, which is get started with Python. So let us create a simple Python Jupyter notebook and try to get started with Ollama. Okay, so for this exercise, what I'm going to do is quickly open my Anaconda prompt, navigate to the folder I want to open my Jupyter notebook. In your case, if you do not have Anaconda prompt, just go to navigator and open Jupyter notebook directly, or if you're using VS Code or anything, you can also practice it there, right? I'm just going to create a new Python terminal, untitled file, and here I'm going to get started with Ollama. Right now, for this exercise, I'm going to first of all import Ollama. Now that comes from multiple, so Ollama directly can be imported from Ollama library. Ollama is also available inside LangChain, right? What exactly is LangChain? I will be talking about it very shortly. Community dot LLMs import Ollama. Let me just run this and see whether it is working. It's working. So my import statement has no problem. And then what I'm going to do is initialize the Ollama model. So I will try to name my model something as, let's say, M is equals to Ollama model equals to Tiny Llama. Make sure Tiny Llama is installed. Sorry, not this one. So I don't have Tiny Llama. Ollama run Tiny Llama. Pulling manifest. Why it's taking so much time? Tiny Llama. Tiny Llama. Okay, let it run in parallel. Let's go and directly call the model. And after initializing the model, then what we need to do is we need to generate the text with the model, right? So here I'm going to call, let's say, response is equals to, let's say, model dot generate. And what I want to generate, let's say, when did India got its independence? Bracket, bracket. And then I'm going to print my response. Ollama endpoint not found, and that could be because of Tiny Llama is not working. Why the context cancelled? Ollama pull Tiny Llama. Okay, pull is working. Run is not working. Anyways, if something goes wrong, I think it should not be a big problem. What I usually do is I just either debug it, and if it's a lot of hassle, I just restart. Like, just uninstall it and install it back, and should fix most of the things, because it's literally very headache free. I mean, I have never faced a lot of issues with Ollama for now. I have deployed applications on Ollama as well for various of our clients who have data privacy concerns. So I have never faced any difficulties and challenges. So yeah, let it run, and then we will directly run this code. Okay, pulling is done. 638 MB. Done. Successful. Ollama list. Yes. Let's rerun this. Should not give me a problem. And here you go. Now you can see that the final output is giving me like generations is equals to, list inside a list, and then generation chunk, and then text. If you only want this particular text, now you need to use your Python skills, right? So what I'm going to do is, so my response is this, right? So from this response, what I can do is, let's say I will do response dot generations, and let's say I print this. Oh, sorry, not this one. uh, Generations, and let's say I'll print generations of 0, and generations of 0 is nothing but the generation chunk, right? From this 0 I want another 0, which is giving me the, if you go back, you can see it is double list, right? So 0 of 0, and that will give me generation of chunk. From there, I just want the text. If you do this, this is what the text is. So India got its independence on da 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 from British colonial rule. The country was divided into two parts, India and Pakistan. After partition, a new constitution was made, which officially established India as a sovereign nation on January 26. So if you take this and directly, if you want to tweak this code, simply instead of print you can do this, or else you can just create a generated text is equals to this, and then you just print generated text, one line of code. And let's say, what is this? This is nothing but extracting the text from the response. Run this. Done. If you want to tweak it, you can see it will return you different answers, but the context is same, right? Let's say if I tweak it to make it hallucinate, of course it will hallucinate. India got its independence on October 5th. Wow. October 15th. Okay. Now this is wrong. It was celebrated as the Banaras Hindu University Day. So yeah, the model started hallucinating. So if you better you ask direct questions, and the model will give you good results. So give it a try with different other models, and I'm pretty much sure you will be able to understand. You can see the answer is still wrong. Anyways, that's all about how to get started with Ollama. Now we shall be talking about the next topic, which is building RAG systems with Ollama. For those who don't understand RAG, I will try to explain RAG again. So it will be like a memory refresher for you all. Now, RAG systems basically stands for Retrieval Augmented Generation. Retrieval Augmented Generation. Okay, now try to understand the problem and then we'll talk about this. The problem is, if you don't use your own custom data and you still want to ask something to ChatGPT, for example, you want to go to ChatGPT and try to ask about why your previous month's Vodafone bills were around $500. Why? Is it because of international calling or is it because of more data usage? What could be the reason? Now, ChatGPT will not be able to answer because it does not have access to Vodafone's database, nor it has access to your own bills. Now, there are 100% chances that the GPT model will hallucinate, right? And that is where RAG comes into picture. What does RAG do? RAG tells us that give me an access to your documents, give me an access to your database. I'm going to make your models better. So using my concepts, you will be able to get answers to your questions. Now, for example, you do have access to Vodafone's database and you also have access to your PDF document. Now these are serving as your documents. What you do is, using some NLP concepts, you break it down to smaller documents and then try to vectorize it and try to store it somewhere. That somewhere could be like, let's say, a database. And now when somebody wants to ask a question, let's say why my bill is higher, then if you ask, the query will be able to call to the database using some sort of intelligent technique and will be able to give you some response, because here you do have access to your database and to your PDF document, right? Another use case is, imagine you have a bunch of machine learning and deep learning PDF documents. Okay, now you want to create your own assistant. That means you want to create your own chatbot using your own documents. What you can do, similarly, you can train the large language model with your own data, and then when you want to ask a question, it will be able to answer from this list of documents. And that is exactly where RAG comes into picture. RAG helps the large language model to overcome the hallucination problem, and RAG also helps you to work on custom data. So solves the hallucination problem and can be used for custom data. These are the two advantages of RAG. If we deep dive into it, this is how things are going to look like. You have your own document. From your own document, you're basically parsing and pre-processing and creating tiny documents, right? Imagine you have a document of 100 pages, right? What you're doing is you're parsing the document and pre-processing it and making smaller data sets, right? You can call it as tiny docs. Okay, after tiny docs, what we usually do is we usually kind of do some chunking. You can merge these two steps, usually can also be done smaller chunks. Now each of this chunk, we create an embedding model. Using an embedding model, we are able to get the vectorized data of each of this chunk. Now imagine, let's say this chunk's vectorized data is 0.5, 1.3, dot 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 something. Now this data's vectorized data is, let's say, 0.6, 1.3, 1.4, dot dot dot. And similarly, all of this vector data you store. Now you can call this as a vectorized data. Now vectorized data has to be stored somewhere, right? Now this is where you store your data into a vector database, right? Now imagine there is a user sitting here. So the user is here, right? Let's say the user has an access to a front end, and through the front end the user is asking a query. Now what really happens is it basically goes through this embedding model and gets the embedding. So let's say the embedding is something like this, and then it basically goes and fetches from the vector database. This is the entire deep dive. Now what does RAG systems need? What does RAG systems need? So let me write it down. We need a large language model. Either you are using a OpenAI model or a Grok model or a Ollama model, whatever it is, a large language model is needed, right? You need a document corpus which serves as your knowledge base, right? That means you are working on a custom use case. You need data for that. You need document embeddings. You need vector store. Vector store could be anything, right? It could be a vector database. It could be a FICE, like Facebook AI similarity search. It could be Pinecone. It could be ChromaDB. It could be anything, etc. Right? And then lastly, you need a retrieval mechanism. These are the most important 5 things what does a RAG system needs. Let's also try to talk about LangChain. What does LangChain mean? LangChain, a language chain, right? Now this is a tool that makes it really easy to deal with large language models and build robust LLM applications. So using LangChain, you can actually do the parsing thing. Yes, you can do parsing. You can do the loading of documents. Yes, you can you can do the splitting of documents. Yes, you can also generate embeddings, because LangChain already has a lot of embeddings inside it. You can do all of these activities using LangChain. So LangChain is a beautiful library that we have. Okay, now before we move into more into the practicals part, let us also get our hands dirty around vector databases, right? I'm sure everybody knows about vector databases. In simple terms, in today's world, whatever you are using like Oracle, MySQL, all these are scalar database, right? They are scalar. To store huge corpus of data in a vectorized format, you need a vector database. Scalar database will not help. Okay, and vector database, or you can simply call it as a vector store, is mostly used for querying the database, right? So what really happens is, so imagine you have, let me just drag it a little bit down so that we can have enough space for doing things. Now let's say we have documents, right? What we do is we do splitting of documents into smaller splits. Now each of these documents we create embeddings. Let me write it down as embedding 1, embedding 2, dot dot dot, embedding n, right? Now this embedding 1 could look like 0.5, 0.3 dot dot dot. It could be an n dimensional space, could be a 300 dimensions. Similarly, this, let's say minus 0.3, 0.5 dot 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 dot, and dot 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 you also have for embedding n. Now this is nothing but your, you can call it as an embedding vector. Okay. Now when a user is asking, let's say there is a user is asking a query, right? What does happen? From the query we actually create embeddings. Logically you should use the same embedding technique that you have used for training your data, else it will not work in the right way, right? And then once the embeddings are created, what we do is we usually go ahead and try to search for the vector data. So this is where the searching happens. I will write it down: search and compare all vectors in vector store. Okay, all vectors in vector store. This is what happens here. Okay, now after that, what comes as an output is, let's say this and this, like these are the relevant passage that you get, plus you also get this. Now these all goes into generative AI large language model. Now this buddy can be anything. In our case here we are going to use a Ollama, let's say a tiny llama model. And then what the tiny llama is going to do, it is going to do a chat completion, and then you will be getting the result. And that basically is the entire flow of how vector store or a vector database works. Now instead of storing the vectors in a local vector index, you can also store it in a vector database. So if you want to explore vector databases, you can always explore Pinecone, ChromaDB. Even AWS and Azure has multiple vector databases as well. Even MongoDB has its own vector database alternative as well. So there are many vector databases already available, because this race of generative AI is going on. Many companies are using generative AI a lot. So every now and then a new vector database is also popping up. But personally, I have experience working on Pinecone and few other things, but yeah, Pinecone is my personal favorite. So in case for practicing you want to use a vector database, we will also use it in some of our future videos. Now that's potentially all about this this chapter. Next chapter we will be jumping into a practical use case using like an end-to-end project using Ollama. Let's jump into the Python notebook. What we are going to do is we will be implementing a RAG application or a RAG system using Ollama. So for this exercise, let me try to help you understand with the use case, and then we will jump ahead with the Python notebook, right? The screen that you are able to see, I think I will be able to explain you from here. Now everything remains the same. I mean, nothing changes. It's just that I'm going to give some names to this document so that you will be able to understand the use case. Okay. Now the use case is, imagine you are a PhD student or a master student, and most likely people who are into writing thesis papers or research papers, they are prone to go through a bunch of research documents, right? I mean, at least I do. I go through a lot of research documents, and sometimes going through research documents could be very difficult. Now difficulty means, let's say I'm lazy, I don't want to get into a 17-page document, right? Now what I want to do is I want to create like a chatbot or like a question and answer system where I can train my research paper as part of a RAG framework, and then using Ollama as my large language model, I should be able to ask anything and should be able to get answers from that particular document. Okay, so in this architectural diagram that you see, now these documents are going to be your research papers. Okay, for this exercise I'm going to just take one paper, and one paper will be divided into multiple chunks. From these multiple chunks we will be getting the embeddings, storing it somewhere, and then as a user we will be asking a query. Query also goes through an embedding layer and then gets the relevant information along with the input query. Then we will be calling the Ollama model. For example, we will be taking Tiny Llama as an example, and we'll be getting the chat completion and final result. Okay, this is what our exercise is. So let's get started. Basic Ollama code, how to work on, I have already explained in the one of the previous videos. Let's go ahead with the RAG with Ollama. Okay, the very first step is installing libraries, installing or importing libraries. Most of my libraries are already installed. In case you face some library installation issue or module not found error, please install these libraries. Okay, so for the first time, for the first line, I'm going to import Ollama from LangChain community.llms, and then importing the libraries, and then let's say I'm going to initialize the model. Let us remove spaces and enters so that we can utilize the space. Now here let's say my model is equals to, let me name it as model equals to Ollama, model equals to Tiny Llama. Done, my model is initialized, and then after that let's say I'm going to generate okay, you know what, before even doing all these things, okay, let's do this. Model equals to Tiny Llama, and then let's say generate answers to a question. Let's say I'm going to ask a question. Let me write down the question as when did India get independence? Okay, and then I'm going to create a variable called as response is equals to model dot, let's let's not get confused with model. Let me just name it as LLM. Okay, LLM dot predict on what, on question. This is also how you can get the response. Okay, and then printing the response logically. Okay, LLM is not defined, yes, because we have to rerun this, and our output should be here. Okay, India got independence on August 15, 1947. It was achieved through the resolution of the Indian National Congress and British Raj to give complete independence to India from British rule, which ended their 208-year-long rule over country. If you want to ask another question, let's say I want to ask something about who is Sachin Tendulkar, I should be able to get an answer that he is a cricketer with blah blah blah, right? Now my basic model is done. Of course, let's wait for the answer. Sachin Tendulkar is an Indian former cricketer. Now let's go ahead with the next step with implementing RAG for custom data. Okay, cool. Now for implementing RAG for custom data, what we would be needing is a few other libraries apart from just Ollama. Okay, so let's get started. So from LangChain vector stores import FIASS. I will explain each of them from langchain.embeddings. Now here you can use OpenAI embeddings. but OpenAI embeddings will also expect you to have OpenAI API keys. So let's say I will be just using Hugging Face embeddings. But if the question is whether Hugging Face embeddings is better or OpenAI embeddings, nobody knows. We have to do a hit and trial, and based on the responses, we should be able to identify which embedding techniques is better for this particular use case. Right. Um, okay. So let's say uh, anything else. Do I have to import? Import open AI from LangChain document loaders. Sorry, import OpenAI. Yeah, running fine. Uh, Let me do it in the first line. Anything else from LangChain document loaders? Import by PDF loader. Okay, and from LangChain embeddings is done. From LangChain, let's say text splitter, we might use a text splitter, recursive character text splitter. Okay, so all of my libraries are imported. Now the very first step is, let's say I'm going to read PDF reader is equals to by PDF loader, and let's say I'm going to pass my file. So let's say my file is already available here, rag paper.pdf. I'm just going to give the full name. Done. And then documents is equals to PDF reader dot load, then text splitter is equals to, I'm just going to call this recursive character text splitter, and then here I have to define my chunk size, and also I have to define few other parameters like chunk overlap and all those things. So let's say I'm going to use 200 for chunk overlap and chunk size, let's say 1000. Okay, let me write down and I will explain you each of these lines of code. Shouldn't be very difficult to understand. Text splitter dot split documents, and then I have to pass documents. Let me run this. Done. Now let's try to create embeddings using a free HF model. I'm going to use a Hugging Face model, right? Hugging Face model embeddings, right? So let's say embeddings is equals to, I'm going to call Hugging Face embeddings. That's it, right? Now instead of this, literally if you want to use, you can also go for a OpenAI embeddings. But the moment you use an OpenAI embedding, let's say you are using an OpenAI embedding, you have to pass the API key. Okay, something, whatever API key you are generating from OpenAI website, you have to pass it, else it will not work, right? So we are not using an OpenAI API key, so I'm going to use a Hugging Face embeddings. That's it. And then after embeddings are created, embeddings equals to this, db is equals to files from documents equals to chunks, and then embedding equals to embeddings. Okay, couple of seconds, and we should be able to create our embeddings, and we should be able to create our db connection FAISs from documents, right? So here what's happening is, let me try to explain these lines of code for now. These are all import statements, very simple. Here I'm reading the file. So if you go back to my row, I'm just reading the file here, and then I'm loading it. Yeah, this is the same thing. I'm just loading the file. This is where I'm calling the recursive character text splitter, and I'm basically doing the splitting part. This part. Till now here I have done the splitting part and created the chunks. So I'm only at this stage where my cursor is, at this stage. Okay. Now here I'm using a chunk size of 1000. What does that mean? That means let's say I'll go to Wikipedia page, Sachin Tendulkar. let's say this is my entire PDF document, right? Or else we can directly open the rag paper to explain. Let's say this is my entire document, right? Now when I define my chunk size, basically that means, imagine I'm defining chunk size as 20, for example. Okay, that means only 20 tokens will be part of the first chunk. Second chunk will be next 20. Third chunk will be next 20, and so on. So 1000 means first 1000 tokens will be part of the first chunk. Now when you define chunk overlap as 200, which means out of this 1000 tokens, let's just remember, okay, let's just remember that the first chunk is still combined, right? Now from combine we have to backtrace and go towards 200 tokens, so which is a chunk overlap. Now let's say from combine till access, let me try to explain in a better way. I think you are able to understand me, but let me take it to Miro board and explain you even better. So okay, I'll try to place it here and try to explain. Right now imagine my chunk size is 1000, so that means from here, let's say till here is my first chunk, right? And imagine if you backtrace, let's say till here are your 200 tokens. So your second chunk will start from here and goes on till 1000 tokens, let's say till here. So this becomes your second chunk. That means there are 200 characters that are overlapped between chunk 1 and chunk 2. This is what is the meaning of chunk is. What the chunk size and the overlap sizes. Very simple to understand. I'm just removing everything. Done. Now, and here we are just splitting the document. That's it. And here is where we are creating the embeddings using some NLP embeddings, word to vector or any kind of thing. Here we are using a Hugging Face embedding. And then here we are just calling the Facebook AI similarity search from documents. Method basically means from these chunks. I'm just using the embeddings. Okay. Now, okay, so let's say now I will just call my Llama model, initializing my Llama model, and then my asking a question is already done. So what I'll do is, just for the sake of writing it down, I'm just writing it down. And then after this, so here we are just calling the basic model, right? And we are asking the basic model. We have not used the rag paper as of now. Everything is ready. We just have to push it so that we will be able to use this model along with the custom data, right? Now this is very important. I'm going to write down from langchain dot chains. I want to import a conversational retrieval chain. From langchain dot prompts, I want to import a prompt template. And then here what we need to do is we need to create a template. Okay, so let me write down it as, let's say, condense prompt template, or else let's say condense question prompt is equals to prompt template, prompt template. I'm not 100% sure. Prompt template. Prompt template. Prompt template. From template, and then we have to pass something. So it basically should be like from template, and then we pass, let's say given the following conversation and a follow-up question, rephrase the follow-up question to be a standalone question. Chat history. um Chat history. Okay, let's say chat history. Follow up input question, standalone question. My template is ready. My question is going to be taken, and then I'm going to use QA is equals to conversational retrieval chain, and this is where I need to call from LLM. LLM equals to LLM, and because my variable name is also LLM, and here I have to pass this template, so I'll have to define um, okay, one is retriever is equals to db dot basically db dot let's take help of chat gpt. Can you fill up the problem? I usually use VS Code and use GitHub Copilot for chat completion, but I think it's retriever db dot, I think, as retriever, and then we have to pass the prompt template equals to condense prompt template, retriever equals to db. No, it's not right. Db dot as retriever, and then okay, let's do one thing. Let's go ahead and check out this conversational LLM. And then okay, contextualize prompt. No, not this one. uh, hmm, LLM retriever condense question prompt. I think I have used the same name but in capital, so you just have to pass this one on this one. Okay, and then if you want to return the source documents, you can return that, but let's say if you don't want to, you can just return it as false, no problem. Verbose equals to false. Now if you run this, it's running fine. Now let's say I'm just creating a chat history. Let's say initially I'm just creating a chat history empty list query. Let's say I'm going to add what are the different methods used in this paper. Result is equals to QA query chat history. The chat history, I have to pass chat history, and then okay, running fine. It's still running. I'm not sure. I think it should be result of answer or something. Let's run this and see. Yeah, it's taking a little bit of time because it has already created a call, right? If you just ignore this and do the print on the next line, it should still work. Make sure that as you are using a Ollama model, make sure your Ollama is running up and fine, and also make sure that your Tiny Llama is also installed. In my case, Tiny Llama is already installed. So make sure that it's already installed. Now if you print my result, oh my god, result has so many things, but in the result, I think it should be just the answer. Bracket is, yes, I can provide a brief overview of the different methods used in this paper to answer questions. The paper uses a different models for ranking Wikipedia articles on their quality and relevance. The first model is an encoder decoder architecture, followed by a token based decoder that predicts da 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 da. Okay. Um, okay, let's try to go through this paper and ask some genuine questions. I'm not sure whether it will be able to answer or not because I already had some bad experiences working with Tiny Llama in the previous video. But this is what it is. My system does not allow me to test it out with some different models. So that's why I'm sticking to Tiny Llama. But we can give it a try. So let's say I'm going to. What are the different methods used? Okay. It's already mentioned. It is already asked. What is a RAG sequence model? Okay, what is a sequence model? Let's try to run this. In fact, okay, it will take a couple of seconds, depending on the capacity of CPU that you have. If you have a stronger CPU, of course, you will be able to run this very quickly. RAG sequence model is a type of generative model. Uses retrieved document. It should be there. I need this keyword here. Uses the same retrieved document to generate the complete sequence. Technically treats the retrieved document as a single latent variable. Do we have this word here? Single latent. It's not there. So key concept of RAG sequence is the use of the topic word sequence as the input to generate multiple. Okay, not bad. I'm going to test it out one last time for little bit complex question like who the authors are. I'm pretty much sure it might not be able to answer. Who are the authors of this paper? Let's give it a try. The query can be answered by using here is okay, it's not able to answer this question. Anyways anyways it's this is how the pipeline works. This is how the code works for a RAG based model. Of course, if you change the Tiny Llama to a larger model, I'm pretty much sure the results will be something very very different. You can run multiple other stronger large language models, but this is how it is. If you want to take this game to the next level to create a Flask application, you can always do that. But in case Flask application part, you can do it by yourself, or else you can go through the multiple projects that we have, take help from that, and you can leverage those knowledge to create a Flask application out of this simple project as well. That brings us to an end to this Ollama module, and see you in the next video.